nearly like YAPC, like Nick talks, whereas until yesterday evening, I had absolutely no idea of what I was going to talk. And yeah, so it's a very short and easy introduction about Perl Internals that I'm going to try to make it in, of course, less than 10 minutes, because that's the rules. So I don't know how familiar you are with Perl Internals, but at least you know that Perl is not typed. But in Perl, you can do a lot of fancy things. You can use undev value. You can use integers, strings, on floating value, list, hash. And for all the first types, as you can see, we are always using the same container. We are assigned to a variable $foo on this not typed when we are using them. So we have list, hashes, function, and also file handlers on other types. Okay. But Perl is designed in C, if you're not aware. On everything in Perl, in fact, is SV, which means a scalar value. On SV is designed like this. Mainly, you have the any, which is a pointer to the body of the structure. You have a ref count, which just it's a simple counter to know how many elements are using the same struct. And then you have flags, and flags are divided in two, where you have a lot of flags like magicals and others, but you also have the type. What kind of SV is it? And then you have one union, because in mainly in C you only have unions and struct. So this is a struct, and this is the union thing that's going to point to one of specific things. So we're going to just have a quick look at SV, and that's mainly what I'm going to talk in these 10 minutes. So Perl is not typed, but SV can be typed. Okay. So the very first one is null. It's one SV null, and then we have NV, IV, PV. The arrow there in these three are very important, because one SV can be upgraded regarding these three, and they can never be downgraded. So which means you can start from null, except null is special, but you can start from one IV and upgrade that IV, which is integer value. So I equal 42, it's one IV, and you can upgrade it to a PV IV, which is one IV that's been converted to a string. PV stands for the pointer, because S was already used for string, so they need to use something. So they came with PV. It's a pointer, so it's a string. So the str hello, it's a PV. The 42, it's IV. The log2, it's one NV. Okay, on the array, it's one AV at the very bottom. And then we have the HV, and we have the IO for the file handler, and the function is a CV. Okay. So how is it designed in C? It's an extract of sv.h. If you already have a look at it, I have no idea. So this is exactly the left is the schema of what we see on the right. Mainly, we should start from the very bottom, where one struct sv. We're just using a head with void star, and then we're using the union things, okay? And the union things can be either the IV value, the UV value, the pointer of the string with the SV star, all that kind of things. And the head is each SV specialized and can have the SV any with a different struct, which will have more or less information. But you always have the ref count on the flags, okay? So that's how it's defined in the sv.h in the Perl code. So the types are very limited. We have about 16 types, and there's a mask. So 0xf is the mask that you will apply to the flags integer to know what kind of SV am I dealing with. Is it one integer? Is it one float? Is it one string? Is it one hybrid like PVIV, PVNV, or this thing? Is it a magic? Is it a regex? All of them. So you have a lot of macro. If you have never checked the Perl codes, if you want to know what type is one SV, you are going to use a lot of macro that will directly do the mask with the defined type there. And SVT, T stands for type. And that's how it works. So we can also play very easily with Perl and understand what we are doing. So if I do this, so I can use devel pick, which is very, very useful to understand what happens behind. I can just set 8 to 42. So this is one integer value. So this is one AV. And if I dump it, this is what happens. I can see my SV is typed as one AV. Ref count is 1. So I've got two flags. I OK, which means I can use it as an integer. It's OK to use it as an integer. The P lowercase is for private usage. I'm not going to explain this there. And IV is the IV value, which is saved. Here, it's tricky. It's saved in the union, as you can see on the bottom right in the IVX things. But one IV, to save memory, does not have any body. The body is empty. So there's a trick to make that pointer shift it back to point directly to the IVX when you access to the SVNE. So that's that's a way to save a few memory there. That's cool. So we have the IV there. And let's have a look now at a reference. I have not talked about a reference, but of course we have reference. So $A here, it's a reference on $A, which means $B is just going to point to $A on the value of where the structure where I save 42 is not going to be duplicated in memory. So if I have a look at this, I can see A, the same as earlier. If I print it just after assigning it, I can see the ref count is 1, the IV value is 42. Then if I say $B equal a reference on $A, I can see now that my $A, the ref count has been increased, bumped by 1, and the memory address exactly the same one, AC0. And now if I inspect B, B will tell me, in fact, this is one IV, okay, but this is a RV on the other one, where the ref count is equal to. On the second, B is going to be destroyed, or A is going to be, the ref count is going to decrease. So ref count is a way to avoid to duplicate struct in memory and to know when we can destroy them. So if you have then lexical things, each time things is pointed like in a hash or a global or whatever, the ref count is going to increase, and when the ref count reaches 0, it will trigger the destruction. The destroy part is going to be triggered when the ref count is null. So that's the ref count. And this is how it can be graphed. You have the RV on the left and the IV on the right, and then you can, of course, chain them as many as you want. So now PV. So PV stands for pointer, so that's a string. And my str equal something, ABCD. And I can see now that I've got POK, and I've got a new flag. So POK means it's OK to use that SV as a string. On isCow, it's new thing introduced in, is it 518 or something like this, where the idea is if you have a string in memory, as long as you are not updating these strings, if it's only a read access, then it's perfectly fine to reuse the same memory part in your in the code. And the only place where you are going to need to do a new malloc, it's when you're going to update it. So isCow just means copy on the right. So when you are going to update that things, we are going only at this time to do a copy. Okay. And that's tricky because the isCow flag in C you have the string ABCD. Of course you have the trailing \0. On the cow there is a cow counter hidden behind it that you can see here display the cow ref count. It just means how many of them are pointing to them as a read-only access. And then you have cure and len, which are different because cure is the length of the string from a Perl point of view, and length is the memory size alloc for these strings in C. Okay, so I don't know why it's 10 because usually it should be 4 plus 2. It should be 6 because you have 4 letters, and then you have 1 extra for the \0, and then you have 1 extra char for the char. But they might allocate a little more memory on demand. Currently, what I'm working on, we are reducing it to be exactly the same size as expected. So a string is like this. So you are using in the union, you are using a PV to point to that string, which is saved in memory. So ABCD And you can see at the end the backslash 0 on the ref count counter. It's since 518. And then you have some, the current lane are saved in the anythings with some, the stash and magic, but I'm not going to talk about them. And that's how a string is saved in Perl. So we can dump it. Oh no, that's, okay. That thing I'm just showing how the cow things can be bumped. For example, I just use instantiate a string, A, B, C, D, and then I push the same strings 4 times in one list. So the string is used 5 times, but in memory, it's only there once. It's not going to use 5 times the size of these 4 characters. So the cow ref count is 5. Okay? Now tricky things. So if in Perl I do my foo equal 51, it's 1 AV. The second I'm going to reassign something else to that storage, like to that variable str, like ABCD, then the string is going to be upgraded as a PVIV, which means it will contain at the same times the IV value 51, but also the PV value. And that's how you deal by abstracting the numerical, the type numerical on strings in Perl. So you see, we start from IV and we upgrade it to PVIV. And if I dump the string just after doing 51 on ABCD, the interesting part is that I can see that the IV slot still contains the 51 value, whereas the PV slot points to a string ABCD. But if I have a look at the flags, I do not have IOK, which means it's totally illegal to use the integer value for now. On the POK, just consider the strings. Sometimes you might have POK and IOK both set at the same times, because you might have 51, which is represented and saved as the integer, but also as the string. So as long as the representation is the same, they match, you will have the 2 flags available for you. And that's tricky because you have some corner case where you can go back to the IV value even if the IOK flag is not set. But I'm not going to talk about it. What you need to know is that if you do this, you can also do this by just doing string interpolation. If I do, then that's probably what I'm showing in the next slide. It will be the same if I do in double quote $C. That I'm just upgrading that's variable to a strings. And here I can see it's only POK because I just forced to add an empty string behind. The string interpolation will have preserved the IOK flag. Yeah. So yeah, there is nothing. Yeah, that's the same, except that the union here contains the IV value. In the union, the union points to the XPVIV is the any use for the PVIV, and that one contains the integer value and information on the strings, whereas the string is set in the union flag, the blue one on the left. That's what I want to show you there. And yeah, probably go very fast, but if you want to learn more about other types, I would definitely recommend to use PerlDoc, Perl, and PerlGuts. But PerlDoc, PerlGuts will just be difficult to read, whereas Rainy Urban has one thing named ILGuts where I steal all these graphs from that will really explain for each version of Perl how things are linked, how they are used, and then you have a few modules that you can play with, DevilPig, B, and I'm not talking about the op tree there. You can use B dparse to have a look at the op tree and how things are linked together. But yeah, I just want to show you a very basic introduction of ASV, and in fact, everything is ASV in Perl. Yeah.
Thank you.